In the year 2008, two separate space exploration missions were launched that questioned the conventional knowledge of the composition of Mars and the Moon. These missions also offered up new opportunities for future study of Mars and the Moon, as well as the possibility of human colonies on those two worlds. The first was NASA's Phoenix Mars lander, which not only confirmed the presence of water ice in the Martian subsurface, but also discovered the previously unknown phenomenon of snow falling from clouds. And the second was India's Chandrayaan mission, which confirmed the presence of water in the Moon. It also mapped the Moon in infrared, visible, and X-ray light from lunar orbit, and used reflected radiation to search for different elements, minerals, and ice. Therefore, the discoveries of water and snow on Mars by NASA's Phoenix mission, and the discovery of water on the Moon by ISRO's Chandrayaan-1 mission can certainly be considered as the discovery of the decade. ISRO gained recognition for its space capabilities, and the Moon mission elevated India's standing in the global space community. India hasn't stopped since then. It has carried out missions to Mars, the Moon, and even launched a mission to the Sun. Astrosat, India's first dedicated multi-wavelength space observatory, was launched in 2015. While it may not have the same legendary status as the Hubble, it should not be underestimated. In fact, it stands out as a significant contribution to space science, enabling scientists worldwide to observe celestial objects in various wavelengths of light. Astrosat has played an instrumental role in numerous breakthroughs, including its contribution to the LIGO mission. LIGO, or the Laser Interferometer Gravitational Wave Observatory, is an international collaboration aimed at detecting gravitational waves. These waves are ripples in space-time caused by some of the most violent and energetic processes in the universe, such as the collision of massive objects like black holes. In 2017, Astrosat played a pivotal role in distinguishing a gamma-ray burst event from a black hole merger detected by LIGO. Currently, ISRO is making preparations for a human spaceflight. ISRO is in the final stages of developing the first test vehicle or crew module for its Gaganyaan mission. I have already made a video discussing the crew module of Gaganyaan. Feel free to watch it for additional details. The test vehicle Abort Mission 1, which is an unpressurized version of the crew module, has successfully completed integration and testing. It's now ready for transportation to the launch complex. This unpressurized version matches the size and weight of the actual Gaganyaan crew module and contains all the necessary systems for deceleration and recovery. After landing in the Bay of Bengal, a dedicated vessel and a team of divers from the Indian Navy will retrieve the crew module. This collaboration between ISRO and the Indian Air Force underscores the diverse expertise needed for such missions, a practice commonly seen in many space programs worldwide. ISRO is conducting these tests to demonstrate the performance of the crew escape system, which is designed to ensure the safety of astronauts in case of an emergency during launch. If needed, this system allows the crew module to detach from the launch vehicle and return safely to Earth. The success of this crucial test flight will lead to further qualification tests and unmanned missions, ultimately leading up to the historic Gaganyaan mission with Indian Vyominaut. Similar tests have been carried out by space agencies globally, including NASA. For instance, during the Apollo program, NASA conducted various tests of the launch escape system to guarantee the safe separation of the crew module from the launch vehicle in emergencies. SpaceX, in partnership with NASA, has also conducted multiple tests of the Crew Dragon's launch abort capabilities to ensure astronaut safety during launch. Russia, with its extensive history of crewed spaceflight, has likewise conducted various tests of launch escape systems for their spacecraft. ISRO, in collaboration with the Indian Navy, has already successfully conducted 3 tests. The re-entry test in 2014, the pad abort test in 2018, and the recent drogue parachute deployment test earlier this year. These tests were essential for ensuring the safe re-entry and recovery of the crew module. Additionally, 6 more tests are planned to evaluate the crew module in various environments, both in the atmosphere and in low Earth orbit, leading up to the first crewed flight of Gaganyaan in late 2024. DRDO, on the other hand, will play a critical role by providing support for human-centric systems and technologies, such as space-grade food, crew healthcare, radiation measurement and protection, parachutes for safe module recovery, and a fire suppression system. If all things go right, we can see Indian astronauts by the end of next year. After the Gaganyaan project, ISRO has a series of upcoming missions. These include the development of India's own space station, a mission to Venus, and various satellite missions. Among them is Astrosat, India's first dedicated polarimetry mission, designed to investigate the diverse dynamics of bright astronomical X-ray sources in extreme conditions. Additionally, there is NISAR, a collaborative effort between NASA and ISRO to create a low Earth orbit observatory that aims to map the entire globe within a span of 12 days. Finally, there's SpaceX, short for Space Docking Experiment. Next in line is the Lunar Polar Exploration Mission, a collaborative effort between India and Japan with the goal of examining the polar surface of the Moon. India's responsibility lies in delivering soft landing technologies. The commendable aspect of ISRO is its dedication to sharing findings and discoveries with the global scientific community. They routinely publish their research in esteemed scientific journals and present it at international conferences. Furthermore, ISRO ensures updates on missions, projects, and scientific accomplishments are disseminated through press releases, official statements, and public announcements. This transparency and collaborative spirit in space exploration serve to benefit both the scientific community and the public. Remarkably, ISRO has achieved extraordinary feats with a fraction of India's GDP. The first moon mission, Chandrayaan-1, which we've discussed previously, was a testament to this. Chandrayaan-3 has surpassed its predecessor, uncovering previously unknown information for the scientific community. Notably, a laser detector on the Chandrayaan-3 rover revealed a multitude of chemicals on the lunar surface near the South Pole, including calcium, iron, chromium, titanium, manganese, silicon, and oxygen. The most significant revelation, according to scientists, pertains to sulfur. The instrument's pioneering in situ measurement in its original space environment unequivocally verifies the presence of sulfur. While sulfur has been known to exist on the Moon since the 1970s, but scientists emphasize that the rover's direct measurement of sulfur on the lunar surface, rather than within a mineral or as part of a crystal, marks an achievement of monumental significance. Sulfur, typically associated with volcanoes, adds a crucial layer to our understanding of lunar formation, evolution, and geography. These are just a few of the achievements that ISRO has accomplished. There are numerous more milestones I can highlight, such as the Mars Orbiter mission, the first Asian spacecraft to successfully enter Martian orbit on its initial attempt, and the mission to the Sun. Additionally, India's Astrosat made significant discoveries, including detecting a coronal explosion on the nearest planet-hosting star, Proxima Centauri, and capturing extreme UV light from a galaxy located 9.3 billion light-years away from Earth. With limited resources, ISRO's achievements serve as an inspiration not only for its own citizens, but also for people around the world.